Hi, this is Igor. Some of you may have seen my work using the Resolve API, but this is my first tutorial on the brand new Filmlight API, or FLAPI for short. I'll walk you through some examples and explain what is it that FLAPI does. This tutorial will be somewhat technical, but even if you don't catch everything, stick around for the examples, which will give you an idea of what's possible with this API. First off, in computer lingo, an API is a set of software tools that allows one application to connect to another application for the purpose of exchanging information or controlling it. In our case with FLAPI, on the client side, there are actually three different APIs, one each for Python, JavaScript, and node.js, as well as bindings for Java. The documentation that comes with FLAPI is extensive, and there's some code examples included with Baselight 5.2. We can connect to a Baselight using FLAPI in a variety of ways. In the simplest case, we connect a single script or an application to a single Baselight on the local network. FLAPI uses WebSocket protocol to communicate over TCP/IP, which makes it really easy to connect to specific Baselights or to multiple Baselights on the local network. And FLAPI can even connect to a remote Baselight anywhere in the world through the internet, as long as we have the IP address of that machine. You will first need to use pip to install FLAPI from one of these two paths depending on your OS. That is all explained in the documentation that comes with the API. I have already done so I will just jump straight ahead to starting a Python 2.7, and we will do these examples right in the Python interpreter. Normally in production you would use pre-written scripts or apps to connect through the API. We're using Python interpreter to kind of walk you through step by step, sort of how I did it with the Resolve API introductory tutorial. So the first thing we'll do is we'll import FLAPI. I'm going to connect to a Baselight that you're looking at. It's running on this machine. So I'll just declare this variable LH localhost because we'll be using it repeatedly. So now we can make an instance, we'll call it C, and then we connect. We have true response, which means we're connected. Here's a very simple test. Let's fetch the application info. This method returns a dictionary, and in this dictionary you can see the keys and values that show the product name, the version, the build number, etc. Let's try something more useful. I'll instantiate the job manager. We'll call it jobman. Oh, I have a typo. Let's fix that. And we can get a list of jobs like this for the LH machine. We have a job called test01 and another job called baselight_gallery. Cool. Let's try to change something in this job called test01. We will add some sequentially numbered folders. We'll do 20 folders, range 20, or let's do 10, just so we can see them better on the screen. 10. The method we'll use is create folder, and we supply the IP address of the machine, the name of the job, and the name of the folder. Since we're doing it in a loop, we'll do it like this. We'll call it my folder, and we will concatenate that with the counter like this. We have a problem here. I'm a lousy typist. This is complete, but as you can see on the left, Job Manager didn't really update. It won't do it until you hit refresh. And here are the folders that we created, 10 of them, starting from 0 to 9. This can be a pretty useful thing. You get the idea how you can automatically set up jobs, which is functionally similar to what my metafied projector does for Resolve. Alright, I don't need these 10 folders. I'm going to cursor up, and instead of create folder, we'll say delete folder, which will wipe out these. Oh, delete, that's not right. Delete folder. And again, we'll refresh, and those 10 folders are gone. So you can create and delete folders. Okay, so the scene 01 has 3 timeline markers indicated with the red lines, and we can read those markers. In order to get to the markers, we first have to open the scene 01, and we do it this way. This method will list all the scenes for the job called test01. And obviously we have only one scene, so we didn't really need to do that because we saw it right here in the job manager. But if we had more of these and we're doing this automatically, then we would use something like get scenes. What we need to do is set up a scene path. What we supply to this method is IP address of the machine or localhost. I'm just going to spell it now so you can kind of see the whole string. Localhost, the name of the job, and then another colon, and the name of the scene. I forgot the quotes. And now we'll open a scene. Open scene. We supply the scene path we have just built. And I'm going to open this because this is already open, as you can see with the padlock here. If I try to do it like this, there will be an exception because it's already opened. What we have to do is open it in read-only mode by setting up this flag. It's all caps, open flag, read only. And now we have the scene. It's an instance, and we could do marker things with it. So let's see, let's count all the markers. We see there are 3 of them, but let's just do it anyway through the API. Get num marks. There are 3 marks. To do anything with these marks, we have to get their IDs, and we can create a list of IDs by doing something like this. So it's a list 30, 31, 32. Those are the IDs, unique IDs for these 3 marks in this scene, scene 01. Now that we have the IDs, we can call marks methods to get properties for the marks. So for example, let's make an instance of the first mark. Get mark for the ID 30. It's an instance. We can run methods on this instance. Mark 1, get note text. Not night text, note text. This is a mark note. When we can get some other properties, like for example timecode, can say mark 1, get record timecode. We're missing the object mark. Sorry, I'm doing this all wrong. It'll be mark 1, and we'll delete the rest of this. We're calling get record timecode on mark 1, and that's a timecode for this first marker. Of course, doing all this from the command line is senseless and prone to making errors, as you have just seen. Before I started making this tutorial, I made a little script to show you what this could look like. We'll get out of Python and run this script, get markers. And this script has just pulled in the timecode for each one of the marks and the annotation and the mark type. These are all timeline marks. So this is just a Python script, and it could also be an app. I made a little app that gives you a sortable table of markers. And it kind of does the same function as that script, but it just presents it a little nicer, and it's sortable and searchable, and you can export it and all that kind of stuff. One thing I really like about FLAPI that's different from the Resolve API is that for many of the methods to work, Baselight doesn't even need to be opened. So let's close it. And I'm going to run that little app again. As you can see, it's running even though Baselight is not open. And if you think of that, that kind of makes sense because the marks are not intrinsically connected to a running instance of Baselight. They are a property of a scene and a job, and all that information is fetched straight from the Postgres database. It has nothing to do with the actual Baselight running. I hope this gave you a little taste of the potential of the Filmlight API. Of course, we can't possibly go through all the different methods that are included in the API, but I'll just tell you in this first drop, most of the methods are concerned with project management, project setup, setting up burn-ins, rendering, kind of things that you would do for dailies processing. And I don't think Filmlight will stop here. I think there will be more features added to the API. I also plan to follow up this with a short demo showcasing connection to a remote Baselight. Thanks for watching. If you're interested in off-the-shelf pipeline tools for post-production, please visit my website, metafied.com.